alignment. It's more like it's the spacing between like the colors that defines the pattern, right? And the shift, it's tough to say, but it's more than one variable. It's more than one color. So you actually get like an actual pattern. And so when that pattern is shifted, when those colors are shifted more towards the red, you get the pattern, right? The element, and you get the shift itself, like the actual distance and how if it's moving away from you or closer to you. So
like you wouldn't get like two colors, like you're not gonna.
It's more than one.
It's gonna be one mixed color, right? I mean,
yeah. Well, that's where that prism thing that I was talking about comes in, because the one color is actually made up of more than one color. Like white light isn't just white; it's like whole shitload of fucking colors. A rainbow.
So you're saying that they basically said that stars are only red and blue? Like that's the only lights coming from stars?
No, it's not
measuring. I mean,
no, it's.
But they're just using the red light, not the other colors that the light is making.
No, okay.
Only the red light.
It also determines mass with their spectrometry.
Well, it determines mass
for some reason. It determines mass. It determines the direction that the stars are traveling.
Yeah.
It determines the elements.
Yeah. So it'll determine the mass by knowing.
Amazing, dude. That's like when I went to
superpowers. I mean,
did you ever go to like the Six Flags Magic Mountain or whatever? And they're like, I'm gonna guess your weight. I'm gonna guess your age.
Yeah.
I'm gonna guess your mother's maiden name, and
Yeah, but this makes sense though, because if you know the element that something's made up of, you can know the mass, because
all they had to do was look at the person. They're like, "Fucking, I know everything about you."
Because an element always has like the same.
It's like those aura things.
Like an element will always keep the same atomic weight or whatever.
You ever go to a fortune teller? Like, I mean, when they're like, can tell you all this shit about you, you're like, whoa.
But yeah, it's more than.
How about a quick test? Let's test this theory, right? What color is the moon?
The moon's probably reflecting like white light, like which it gets from the sun.
Okay. Now, what does that tell you about what it's made up of, and how far it is, and how fast it's moving? Is this how we calculate things on the moon, by looking at color? Can you send a spacecraft out? Is there a spacecraft that's ever gone out and looked back and took a picture of the Earth and saw the color of the Earth and was able to match and predict what would be on the Earth based on color?
Then it probably doesn't work with like solids like the moon. It probably works only with like with like stars, and that's it. I'm pretty sure.
Because those are not
like
solids.
A superpower.
I'm pretty sure. No, I'm pretty sure we didn't.
All right. Then here's another question then, right? Because they're saying they're discovering planets that might be like Earth and that might have life on it. How do they detect these planets, and how do they know how far it is from that sun, and how do they know which color to look for to tell them that there is possibly life here on this planet? Just by looking at the color and the way the light moves? That's how you know all this?
I mean,
do you believe this shit? I mean, do you really believe this shit?
Yeah, I do. But there's probably more to it. I just don't know it. But
yeah, there probably is more to it.
No, it's fairly simple.
Because check this out. You pass a light through a prism, you're only gonna get that one spectrum. Is like, are we using different prisms or something, or like different type of?
Not all lights. Some lights will like not have, like, for example, they won't have the whole blue section. Like all of the blue would be out, but it'll have the other colors. Like not all light will give you all the colors. You know what I'm saying? Like
that's how they determine the elements. But then again, I go back to like it would be if it's like red shifting and it's like a red planet, whatever that I don't know what red means for the elements. I guess it's like,
well, it's not just one
hydrogen
color.
Or something. I don't know.
No, it's not just,
but
it's not one color.
Wouldn't it be like a mix of like both of them? It's like, be like this is actually xenon gas planet plus a little bit of some other gas, hydrogen gas.
So yeah, if it's a purple planet, that means it's red shifting and blue shifting. Like
no. Let me just let me just
let's use an example. How about Venus? Can we use Venus as an example?
Yes,
perfect, right? Okay, what color is Venus when you look at Venus? What color is it?
you wouldn't use the color the way that we're saying it, like purple or even
What
okay. So let me
special
clear up three things.
microscope and lens do I need and filters do I need to look at Venus so that I can see the color that you want me to see?
Let me clear up three things real quick. The red shift and blue shift, it doesn't mean the actual. It doesn't mean the color itself. It just means that it's shifted towards that direction. So red just means lower number on the list and or higher number, I think. And
So Venus being really close to the horizon and all this atmosphere has nothing to do with the color of it. It's just redshifting because it's moving. It's moving, right?
no, but we actually don't use it for Venus. I was just saying you could. And the second thing I wanted to clear up
Okay.
was,
So the
yeah,
question
you
is,
could.
how far? When do we start using that technique or method of determining these things accurately? How far away does the star or a planet have to be before we can accurately use that method of
No, we can use
color
it.
and redshifting
No,
to
you can
determine
use
the
it.
properties and the materials and the distance and all the other awesome stuff happening in that solar system?
You can use it here even. You just like we used it on the sun back like 300 years ago. It's just you don't at this point we don't need to because we have more sophisticated equipment. But yeah, you can use it here, and what they do is they break it up so you see a huge. You basically see the color split up into a wider range, and so you can see the whole thing. And yeah, even if it's multiple elements, they'll be layered on top of each other, and so you'll have to kind of dissect it and split them up and see like what exactly is there. Because it'll be one color, but there'll be space on top of each other. And the last thing I wanted to clear up, because he was saying, or somebody was saying, like I don't know how, like about looking at something like it'd be a solid object or a burning object. Basically, everything that you see, every color that you ever see at all, if white light is shining onto it, basically the electrons in it are going to absorb a certain amount of it, whatever light it can absorb, and it's going to emit a certain range of that. And that's where that barcode comes from. That's why when you see certain things, they're green, it's because it absorbed everything else and it's reflecting just green.
Okay.
So when
Oh yeah,
barcodes.
I was
we love
I was talking
barcodes here.
I was talking to my ass. I'm sorry.
that just contradicted. But that contradicts what you're describing. If what you're saying, if you're trying to use that, then you are contradicting what you're saying about the sky. You're saying that the way we see color on Earth with an atmosphere is the way we're going to see color when we look out into the vacuum of space. So if I look at a leaf and I see green, and I look at a planet and it's green, that planet is made of trees, of leaves. I mean, I don't know. Is that what
someone earlier brought up basically what you're saying is that we have numbers that represent colors, right? I mean, that's what we're doing is we're turning colors into numbers by coming up with measurements of all types. And measurements are in numbers. So tell me what the numbers are associated with colors.
Okay, so the green, the leaves are reflecting green light, but there's a difference between reflecting and emitting. Okay, and so that's why when you look at stars and they're emitting something, that's where that comes from in that spectrum. So green grass doesn't actually emit green light; it's reflecting the green light. So when you're using these tools, you're using them. That's why you use them on stars specifically.
What the fuck bullshit? You just said you this is where the barcode system comes from, and now you're saying you don't use it. You only use it on stars. I'm gonna call it bullshit.
No, that's I'm talking. Yeah, I said about the emission and absorption line. That's why I'm trying to make a distinction between that and what you're like looking at directly. You're like,
But
it's
many
not. You're
things
not.
are
It's not
green.
precisely.
Many things are green. Many things are different colors or the same colors. I mean, how can you say this light in the sky is made mostly of this chemical and this element because of this color? I mean, what the fuck, man?
My pillow is red, so it's like red shifting right now.
They
it's red shifting right in front of my eyes, guys.
They have identifications, but just like you see salt and salt's
blue
white,
is being absorbed by the pillow.
yeah, when they burned the salt, they see for the emission lines, they see it was yellow. That's all they did back in the day, like 300 years ago. They just burnt a bunch of stuff and were like testing the color spectrum, and they got these identifications back then. But when they're using it on things like say for instance like another planet's
Back
atmosphere.
then, they didn't want me. Now I'm hot. They all on me.
Bunsen burner tech. Of the Bunsen burner tech. Like we can discover what the stars are. Get out the Bunsen burner.
Yeah.
We can discover like how far they are, if they're moving, like how much they weigh, like all kinds of shit. Just let's get out the Bunsen burner. Let's do this.
There is no more to it, Kosho. There is no more to it. That is how they determine. That's how they come up with the story. They tell you, oh, planets with life and all these things. We believe that these planets are this far. It's all based on the color of the light and the movement of the light and determining which light is which. And
the truth
all
is
from that. And if you believe that.
No, but they don't even say that. The truth is they the true people who are doing this work, they don't know what these planets are on, but they can infer and they can deduce what it's not and how big it is, and they have to take a lot of clues in, and they give you their best their strongest, most confident I don't want to say guess, but basically what they have at this point. The stars are different. They can see what those are, but the planets they have to use inference basically by seeing like how much light it takes away or how much dimmer the star becomes when it's orbiting it or when it's blocking it or whatnot, and then it can pick up some of the emission lines when the light's coming through it from the sun coming through the atmosphere. But obviously they can't see it, so they don't know exactly what it is.
How do you see what the stars are? Like just looking at them, you can see. I looked at it,
guys. I'm gonna post a picture right now.
I looked at it, and I know what it is.
This is my understanding of how this works. All right, I'm gonna post it real fast. Essentially, I believe it's this like the spacing, I believe, between like these colors, whatever. So for example, with element A, it's this certain spacing between the first and second one, right? And the third one is like really spaced out, right? And then if you like put that on like on the spectrum, right, you get like an orange, like a weird yellow, and then a weird like light greenish blue, right? But then if you go to the bottom, right, a blue shift of that would be like, see how everything's like shifted to like the right kind of? That orange, that first one is now more like a yellow orange, then that yellow is more of a green, and then that weird like teal blue is more like a blue.
At what temperature was this experiment performed?
No, I'm just giving you an example. This is just so you can understand how the shift works.
Like this is real scientific stuff. At what temperature?
No, there's no temperature. This is just. So
it doesn't matter what temperature you burn stuff at. Like
no, this is just to grasp the concept. That's it. That's all this is really for. Like to show like that's how the shift works. Like there's a shift.
The concept.
Yeah, the concept. There you go. Yeah. But you kind of this is my understanding of it. I could be wrong, but that's my understanding of it.
Yeah, man. Every time an airplane flies over and I see the lights on the airplane, I can tell how big it is, how many people are in it, how much it weighs.
It's not noticeable.
How fast it's moving.
Yeah, that's not really how it works. But anyway, and who's to say there isn't flaws in the way we do this? I mean, there's possibility of that happening because not too long ago, and I think recently or whatever, we've been like getting like
human error. Like human error?
Yeah, it could be human error. We're not denying it.
Man. Science. There are no errors. People are perfect. Didn't you know? Come on.
Science doesn't deny like human error. We don't deny that. We acknowledge that.
You flourish. You flourish in human error, right?
The issue is you're using concepts as science. Concepts to prove an argument. Like, red shift, blue shift, yeah.
No, it's not. It's not to prove an argument. It's for you to comprehend it. It's for you to grasp the idea. It's not to prove it. Details. Because if you can't grasp an idea, how are you?
This is why the universe is expanding. This is how you know. And it's a concept. Evidence, exactly. This is what you're using as evidence. That's a strong word, like proof, like holds up in court, right? This concept.
Yeah, there's no proofs in science. It's not there's not even one proof in science because it doesn't deal in proofs. So, and
damn, man, you're still a glober. That's odd.
Is there only evidence?
But you know what? Because the thing is though, it does a a really good fucking job at predicting though. It does.
You like the lie? You like how they lie?
I like how they predict. 99% of the time.
It's admirable, isn't it? It's beautiful, isn't it?
It is beautiful because of our technology.
Have you ever we stared at it, Morpheus? Just at its beauty. The Matrix has been. I was going to give the speech, but yeah, that's what you say. It's so beautiful.
You're lucky I like you, Bong. All right, because of those references.
Don't ban me, bro. I didn't do nothing.
Hey, with that picture that he posted though, it is a neat explanation. So to put it in perspective, there's like a 400 nanometer difference between the colors that we see, plus there's a much larger spectrum. So the elements that are in a star, there's really there's less than 10 that you're gonna find. There's mostly just 2 elements and about 4, 6, some of them as much as 10 elements. So these lines that you're looking for, they do have specific signatures. And that top and the bottom one, you can see how they're identical. Like you can see how the like he was saying, the distance between them. Like I was saying, like a barcode. Like there's a definition to each of those elements. And if you find something, it's very random. That it would be a huge coincidence if you got that exact combination. Especially every time when you don't find other combinations. And so when you find this exact combination moved over slightly left or right, that's how they determine the red shift or the blue shift. And I know that there's controversy in that, but they have found that consistently, the further away they look, the further they're shifted to the red. And it might be backward. It might be blue shift that's faster.
So
how do you prove these elements?
They did that like 300 or 400 years ago. They started burning a bunch of stuff.
Coach, no, it's shifty, all right. I'm with you on that one, buddy.
Yeah, just
burned a bunch of stuff.
Just test it out.
Is this how they look back in time, like 13 billion years too?
So basically, have you ever bought those packs that you throw in the fire? Like if you have a fire, you can buy these little envelopes at the store. You throw the envelope in the fire, and it'll make the flame come out a bunch of different colors. Is that basically what you guys are trying to say?
No,
it might be. Like I said, when they used to burn stuff, you can do it with table salt. You burn it and it comes out yellow or whatever.
Are you
trying
to say they don't burn stuff anymore? Is that what you're saying?
How did they look back 13 billion years? What did they do to see that 13 billion?
Well, every time you look at the stars, you're looking back in time. So the closest
star. What did they do?
You said how did
they figure that out? How they figure out the
speed of light?
Crack of shit. Let me explain to you what that means, okay? You're not looking back in time. You're looking at a messenger that has just arrived here that took 13 billion years to travel. You're not looking back in time. You're looking at a 13 billion year old proton.
How do you prove that?
It's light speed.
You're not that godlike yet.
Yeah, but how do you prove the distance to these stars? If it took 13 billion years for the light to get here, how do you prove that distance?
Even Mars itself, which you can see right now in the sky, it would be like 20 minutes ago.
You know what the proton said when it got here? Is like silly humans. There's no such thing as space as time travel.
So how do we measure the distance to Mars then?
I was just really hoping it was the Bunsen burner again, because the Bunsen burner star science is badass. I was really hoping it was another Bunsen burner.
Probably is.
How do you measure the distance to Mars?
There's a couple ways. I know with Venus, I think
I said Mars.
Yeah, no, I'm just thinking about how when they did it with Venus, they just waited till it occulted the sun.
When we put reflectors on the moon, Mars.
Yeah, I know. But I'm giving bro. You wouldn't believe it, but when they measured the distance to Venus, they actually got the distance of everything in the solar system. because they knew the ratio
So how they measure the distance to Venus?
That's what I was trying to say, but you guys were making jokes about it. When Venus occulted the sun, basically they were able to, I forget exactly how they got the angular size of Venus, but they used the time it took to cross the sun to get both the ratio of the Venus and then the sun, and then they had the ratio of the other planets.
Hold on a second. You just said a key word, ratio. That's the very key word in your story.
You're right, it is.
I'm pretty sure they sent a giant rocket up that giant V.
Oh. So when you say ratio, everything's based on a ratio. So if you change one number in the whole system, everything just changes accordingly, and it still works out. So the math doesn't really prove anything in the end.
No, but that's the thing, though, is they didn't change anything. Basically, that
measurement... No. What I'm saying about change is if they don't have one number right when they're working off these ratios, it just all fits back into place anyhow. It's not going to matter in the end. In other words...
You're right. You're right in a sense that once they find out new numbers, they get a more precise measurement of the rest of it. Yeah.
Or they're reverse engineering to a more... Or they're... An alternate view is they're reverse engineering the system into a more perfect system.
Yeah, but that's not a bad thing. They're going to get more precise based on new information.
You're missing what I'm saying.
I get what you're trying to say, but
it to what they want it to make the numbers fit more properly. It's just ratios.
Did they know how big it was before they knew how far away it was?
Say it again, I'm sorry.
Which one did they know first? How big it was or how far away it was?
Venus, I think they knew the size first. But I can't tell you exactly.
But how do you decide the size first?
Can you just say you don't know? Do you ever say, Coach, do you ever say, I don't know when you don't know? Like, do you ever use that? I just said that.
I literally am saying that now.
No, you didn't.
I don't know how they got the size of Venus.
You said probably yes. Probably yes.
No, I know that they had the size first because I know the.
No, you're wrong. Oh my God, dude.
When they occulted the Venus occulted the sun, that's when they got the other numbers. Like that's when they matched them all up. But even that measurement itself is obviously not a perfect measurement. So
when did they do this?
A closer estimate. I think 300 years ago, but
okay,
200.
Yeah. Okay, that's all cool. Like here's the problem that I find is that all these, oftentimes when you talk about this stuff to people that are trying to explain the globe, they go to 300-year-old science or 500-year-old science. What about modern day techniques? Like, why are we always resorting to 300-year-old measurements in science? What about today?
Explaining how we first got it. We, of course, have much better, like you were saying, like as you get new information, the numbers, they get more precise.
So
much more precise.
It started with Venus. And you said it, and you can correct me if I'm wrong, but it takes 20 minutes for the light to travel from Venus to here. And I asked about that.
From Mars. It's a range from 4 to 20 minutes.
If I'm not mistaken, it started with Venus and you changed it to Mars. Or was it the other way around?
You asked about Mars and then I went to Venus.
Okay, so let's stick with Mars in the 20 minutes comment. So how did they know the distance to Mars? How did they figure that out?
Well, they initially got it from that Venus measurement, and more recently, we have craft that are there, and they send us information all the time.
So how did they measure the trip to Mars based on this 300-year-old measurement? Is that what you're suggesting?
Basically, in that 300 years, nobody just slept the whole time, People were doing work ever since then.
So what's the modern day? Okay, so let's try to get down to the brass tacks here. What's the modern day method used to measure the distance from Earth to Mars?
Like I said,
I'm assuming there wasn't an odometer on the craft, dude.
No, you don't need an odometer. You just
right. So it doesn't mean anything.
No, you just
ping it, like GPS it. Punch it into the Garmin GPS system or what? What does ping it mean?
You see how long it takes for the light to get to it and then come back.
Oh, perfect. Now we're starting to talk. Okay, so how far? So you're sending light. You're telling us that it takes 20 minutes for the light to travel from Mars to the Earth. So if we're sending light there and back to measure, we're talking about a 40-minute round trip, according to what you're telling us. Well, you quoted 20 minutes.
Yeah, I said 4 to 20 minutes. I to make it clear, I said 4 to 20 minutes. It's a range from 4 minutes.
Maybe you're making it clear now, but you were pretty sure it was 20 minutes a little while ago. You said when we're seeing things from Mars, it was 20 minutes ago.
Yeah, so I made it clear. It's from 4 minutes to 20 minutes, depending on where it is, and it's in relationship to where we are.
So when did they ping it? Where was it when they pinged it?
They probably ping it all the time. I don't know. I don't know when they probably pinged it all over the place. But they don't necessarily need to ping it. They're usually just sending information.
Sending information to who?
To the rover. They're sending or receiving information.
With what kind of technology?
Antenna and transmitters.
An antenna. Have you tried to get cell service in the middle of the bush?
No.
You should try that someday. It really sucks.
Yeah, they don't use cell phones.
I understand that, but the antennas. So, what kind of antenna are we talking about?
I can't tell you.
How big would the antenna be on the rover?
NASA, and the one on the rover has a small one, but yeah.
Yeah. So, whatever the technology is, does it need a medium to travel through, like sound?
No.
Okay, so when you send at the worst, at the better end of the scale, you're saying 4 minutes. At the far end of the scale, you're saying it takes 20 minutes. So at the far end of the scale, it's a 40-minute round trip for this information to go from the Earth to there and back.
Yeah, that's right. So if we're facing each other.
So we have the Earth traveling at, around the sun, it's roughly 500,000 miles an hour. So that's almost 40 minutes is pretty close to an hour.
No, it's like 65,000, but yeah, it's still
pretty fast. 66,600 miles an hour. Right, sorry. And the sun is moving 500,000 miles an hour. Ish, give or take. So, and then Mars is moving. I don't actually know how fast Mars is moving, but I'm sure it's moving at quite a clip. So in this 40-minute time, everything is kind of all jumbled up, wouldn't you say? Like, how does the information get back?
Light goes very fast. Light goes about 300 million meters per second.
That's fine. I don't care how fast it's going because you've already made the claim that it takes 20 minutes to travel from there to here. And that's based on your very fast speed.
Yeah, but you're bringing up speeds of the Earth and stuff, and that doesn't matter. I mean, that's very negligible compared to the speed of the light itself.
Actually, that's not true because we're talking about 40 minutes later. We're nowhere near the same spot that we were when we sent. Nor is not only that, but Mars isn't in the same spot from the minute that we send off Earth. Mars is 40 minutes in a different direction. Then if it does actually make it to Mars, Mars is 20 minutes in a different direction. And then if it does actually get to Mars and starts to come back, we're going to be 40 minutes in total in a different direction.
That's why don't use the 40 minutes then. Just use the speed there because they're not going to base it off of where the Earth was when it sent the message. When they're sending the message back from the rover.
You can't talk like that, though. You can't say, don't worry about the time, it's all about the speed.
Yeah, so when they're sending it to the rover, they can, they just know where Mars is at that point. They don't need to be exact enough to see, okay, where's it going to be 20 minutes maximum from now, which is not even going to be a whole planet away, basically. It's going to be, it's less than a whole diameter of Mars.
The Mars rover takes up a whole planet?
No, I'm saying the
Mars
we're
talking about sending information back and forth from the Mars rover. Wait.
Yeah, but I'm saying Mars itself isn't going to have moved far enough to where it's like even a diameter away from where it was.
How big's the rover?
It's tiny. It's like a small little rover, you know.
Like okay, so why are we talking about planet-sized things when we're should be talking about car-sized things?
They don't have to aim. They don't have to aim exact. They don't have to know exactly where it is to aim it at it. You know what I mean? They
don't have to aim exactly. Mars rotating too? Like I don't know. Is Mars like the moon where it's locked? Its face is locked towards us, or
there's another good point.
No, exactly. You can't do if it's.
And what about what about the Earth rotating? By the time this 40 minutes gets back at 1,000 miles an hour. That's 1,000.
If these guys were like on day one and they just got out of school or something, and they don't make mistakes like that. They know when it's facing the other way, and they know when we're facing the other way.
So we shouldn't question any of the methods whatsoever.
No, you should question it, but I mean, you should know that if it's that obvious of a thing, they know this. Like they can't send messages to it when it's facing the other direction, and that creates a problem sometimes. I forget what there was an issue one time with that, but I forget what it was. And same thing with the Earth. Like we have so many different things all over the world for that reason.
Are you a CGI salesman?
No, but what does that have to do with CGI?
I don't know. I'm just playing.
Everything.
It just seems like I'm about to be sold some CGI.
When you send a signal 40 minutes round trip away and the Earth spins at 1,000 miles an hour, that's almost an hour. So that's at the equator. Of course, it depends where the signal was sent. That could totally make a difference about how much the Earth moves. But nonetheless, it's not going slow. The Earth has rotated. Mars has rotated. The Earth has moved. Mars has moved. And all this just happens to perfectly line up every time.
Hey, I'll help you with your pitch. Don't use the word occulted.
No, you spelled it wrong. It's OCC. Yeah, but anyways, I think you're understanding it. Let me just see if you're understanding it like this. Like I think you're understanding it as if like kind of like a laser shoot, like you're shooting something at something and waiting for it to bounce back.
Well, that's not exactly. Sorry, go ahead.
I'm sorry?
Sorry, go ahead.
Well, no, it's not that kind of concept. It's more of a concept of we're sending it a signal, which is, it's light also, but it's not like we're waiting for an exact location for it to bounce to and bounce back to. We're sending it a signal, and then we would ask it to send us a signal back. You know what I mean? So in both of those computations would be separate. They wouldn't be like, we wouldn't be planning the whole thing from where we are now. Like once it's at Mars, they can kind of test to see if we're still facing this way. Of course, if it's like 20 minutes later, we will be. But
I just imagine them like in Star Wars, this information is going out like the when they shoot those laser beams off the starcraft, pew 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 pew, they shoot it across the galaxy. These bursts of information, right?
Yeah. Well, that's another talking about these speeds. These speeds are really there's a reason you don't really hear them is because they're not used in this way, especially the rotational speeds. I know that sounds like a fast it's definitely a fast number, like 1,000 miles per hour, but it really doesn't apply to anything. It doesn't apply.
Oh, of course it doesn't. And we shouldn't be talking about miles per hour, should we? We should be talking about minutes of angle, right?
No, well, if you want to be practical, you would talk about rotations, rotational speed.
Yeah, and the
same
angle
car, actually, you do miles per hour.
Yeah.
You don't talk about the rotations of the tires or of the crankshaft. You talk about the speed it's traveling down.
And we're totally discounting the fabric of space time and the gravitational influences on this information.
Yeah, like if you guys think that the gravitational pull of the Earth affects the bending of light on Earth, how are they taking into consideration all the different bodies that these signals have to pass through, go past?
Yeah.
That have
I don't think that's the case, though.
Well,
I really don't think that Earth has that much effect on light.
Oh, so then that's an interesting thing to say.
Not so really. Then when they did
long distance pictures that are taken, that's not light bending over the curve.
No, refraction and light, or what do you call it, or gravitational lensing. These are two totally different concepts, completely different concepts.
So you're saying that it's not
lensing.
Gravity doesn't affect light, then?
No, it does affect light, but I'm saying Earth's gravity.
Does light bend in space around objects or not?
It's not that gravity's... Yeah, so gravity bends space-time or warps it or whatever word you want to use. They're kind of all confusing what it actually is, but it's changing the space-time. It's warping is a good one. But either way, so the light's still coming in a straight path, but because the space-time is not necessarily straight there, it's going to look like it's curving. And that's the same thing with mass itself and things going towards each other. They're not exactly it's difficult to conceptualize without using the fabric or the trampoline example or something like that, because
the trampoline example isn't a good example, though. Let's face it, doesn't really explain what they're saying.
Well, you can observe it that way. That's why
all as you can observe is there's a heavy ball in the center that's causing the trampoline to sag, and everything else is gonna therefore fall towards it.
Well,
that's all it shows.
Anything you put on
that is exactly true.
If that is a good example, if that is a good example, then space-time is flat. It's a flat.
No, that's
plane.
one of the flaws of that example. Is that's a 2D example of space-time.
Also, it's not a good example. Okay.
So why not just admit right off the hop it's not a good example?
Because
that would have been made life way easier.
I'm giving you the
I know when I said it's not a good example.
The light.
I understand. I said it's not a good example, and you said no, it is a good example.
No, it's not a perfect. It's not.
And then you said it's not a good example. Now you're saying it's not a perfect.
It is a good example. It's one of the better ones we have, but it's not good. It's not good to say that
it's a good example because it was Einstein's example, comparing it to a fabric. That's why the example is still around, and you keep saying it's a good example, knowing it's not a good example.
It helps somebody conceptualize it who doesn't understand it. Hold on. It helps because you guys are saying I'm saying something else. It helps you conceptualize something that maybe is new to someone, but if you're trying to get a precise description of it, you have to get more in depth because it's not a precise picture.
It's a false concept is what I'm saying on the conceptualizing aspect. It doesn't even... It's like trying to prove gravity and the spin of the earth by putting water in a pail and swinging it over your head and saying that's how gravity works and holding water on the earth. It's the same type of bad concept
idea.
You
explain it to uninitiated people. You explain it to kids, you explain it to students. It's a good way to do that. But it's not good to say it proves anything.
When you say wait, man, when you say uninitiated,
I caught that too.
Dude, when you say that word, right? Like who uses the freaking word initiated and non-initiated? Like who uses that word? Who uses that to say if you are not learned, if you have not been taught, if you did not learn this, if you have not been initiated, right? So who uses these? Why are you using these fucking words, man?
Because it's a word. It's not. It's an appropriate word.
With Venus occulted the sun. Right, to the uninitiated, I'll tell you who uses these words. People who are in some kind of secret society who are trying to talk.
Okay.
Like,
dude,
look, in order for you,
word.
No, man, no, it's not an astronomical.
You're nitpicking.
I swear to you, it is. When something
I was just hoping that this whole idea of light bending in space would explain why the moon doesn't block out stars. I mean,
no, the moon has less mass than the Earth. So the moon's not really involved with gravitational lensing, and I don't think the Earth really is either.
So does the moon block out stars or not?
It blocks them, yeah, when it's in front of them. You can see this during an eclipse, even.
He's referring to exposure. So, like, you know how they have like a shot of the moon, but there's no stars in the background. It's the exposure, but he's trying to get an answer for that.
No, I'm trying to get an answer why the moon in the new moon phase does not block out any stars. Zero stars.
Because there's no stars. Because on a new moon phase, the moon is almost always rising and setting with the sun. So the new moon's not out at nighttime. It's out during the day. So it's gonna be blocking out stars, but you're not gonna see the stars.
You've never seen the night not have a moon?
No, you said new moon.
Okay, so you say the new moon phase is only during the day.
It usually, it's depending on I think always, it rises and sets with the sun or it'll be shorter than that. So either like the moon will be out, the sun will be out longer. But either way, it's all during the times when the sun's going to be out, because that's why it's the new moon, is because it's basically on the same side of the earth that the sun is. And so it is going to appear about the same times the sun's out.
So then when's the full moon phase is supposed to be?
When it's on the other side.
So only
when the earth is between the sun and the moon.
I see all phases of the moon during the day and night.
That's not true. But yeah, you can test this yourself. I forget what phase it is right now, but either way, the crescent moons, they'll always every single time rise or set, or I'm sorry, they either follow the moon, or I'm sorry, they'll either follow the sun as it's setting, or it'll lead it as it's rising, because there's two different crescent moon phases. And the new moon phase will always be when it's closer to the sun, so it's always going to be almost rising and setting with the sun, but it's obviously different schedules, but around that time. And then same thing with the full moon. The full moon will usually be rising when the sun is setting, and setting when the sun is rising, or a little bit before or after.
Go show. The earth is flat.
Right, thank you.
Yeah, obviously those observations are easily disproven just with photography.
No, I mean, I've been doing astronomy since I was a little kid, and I've only ever witnessed these things. So I've never witnessed, if I would have noticed anything out of the ordinary with those moon phases, like if it was happening at a different time, I'd be like, oh, what the heck? I mean, you would notice it. And same thing with the half moons.
So what time exactly would you like me to find a full moon phase?
During that time of the month, but I mean, like I said, they will.
So not time of day, just time of month, not time of day.
No, I said they're once a month. I forget what phase it's in right now. I think.
What time of day is it impossible to get a full moon?
Oh, let's just say noon.
Okay. I'll find the full moon and noon.
Probably Google that right quick and find one. Hey,
time day doc.
How do you explain flat water?
There's no carbonation in it. I don't know. Well, you talking about?
That's pretty funny.
Yeah, you talking about because of the bending of the earth or something like that?
Well, it's visibly flat, is it not? Like,
yeah,
level.
Visibly. At least to the horizon, yeah, it seems that way. But no matter where you are on the earth, you see to the horizon, so things are all gonna.
So, how much curvature would the Earth be in 2 miles? Would you say?
It depends on what you mean by how much curvature. If you're talking about,
over water, how much curvature? How much measurable curvature would there be over 2 miles of water? Like, let's say if you could measure it,
roughly 0.6 of a degree.
How many inches is that?
0.06 of a degree. So that's what I'm saying. It's a very strange concept to measure curve by height.
Yeah, that's fine. But how many inches would that be?
If you're talking about the height in 6 miles,
yeah,
that equation that you guys do is a bit strange. But yeah, you'd have to do like the tangential fucking line, and then.
Could we agree it's roughly around 16 inches?
Yeah, because of the
give or take.
Well, because
I said 2 miles. Sorry, to be 32 inches.
Would be 36 times 8, or
no, it'd be 32 inches. Could we agree that it's roughly around 32 inches, give or take, even 10 inches for all I care?
Wasn't it 6 miles squared?
No, 2. I said 2 miles. 2 miles.
2 miles.
2
okay,
times 2 is 4. Times 8 inches is 32.
Sure, yeah.
Can we go with that? Can we agree with that?
For the sake of this, yeah, but I'm sure it's just a little bit off, but yeah.
Okay. And so, how many degrees did you say? Half a degree?
No, I said 0.06 of a degree.
Sorry, so 0.06 or 0.06?
0.06, and actually, yeah.
Okay, so 0.06. So let's do a little bit of a mental experiment here. Let's say we took some light gauge steel, like let's say 14 gauge steel or whatever, right? And we it was, let's say it's 6 inches wide and it's 2 miles long, and we gave it a 0.06 of a degree bend over the 2 miles, or it would roughly work out to be 32 inches. Then after that, after we put this precise bend on it, we leveled out the ends so that this thing it's leveled, right? So each end is at the same height. And then we welded 6-inch sides across the 2 miles of this thing, and at the ends, the 6 inches. So basically, it's a 2-mile tray that's 6 inches wide. Okay? Do you got this picture in your head?
Kind of. Yeah, I think so.
So
Basically,
then
it's a long bar, it's bent to match this curve.
Right, and it's got sides on it, so we can fill it up with water. Now,
okay, I see.
So now we got this 6-inch wide piece of thin steel that spans over 2 miles. The ends are leveled out, and it's got sides, so it's a tray that can hold water, and it's watertight. Now let's pretend that we walk a mile from one end, so we're directly in the middle of this tray, and we start to pour water on the middle of this tray. What's going to happen, do you suppose? I mean, we could actually do this. We could actually do this, but I don't think we even have to, because I think we know what's going to happen.
Well, the Romans did this, and rivers do this naturally. But if I were a scientist and not making a bet, just making a scientific prediction, like a hypothesis, I would hypothesize, or I would predict that the water wouldn't really move. It would relatively, as long as it's perfectly level, other than the description you just gave, was supposed to match this assumed curve, then I'd say it would stay relatively in the same spot. It would.
The prediction would be that the water would run to the ends until it makes a high enough level at the ends that it overtakes the hump.
Right, that's what you would expect if you were on a flat plane and you made this same object. That's what you would expect.
So we could do this experiment and actually test it and see if the water, because then you could walk along this 2 miles and see. I mean, you have a 6-inch rim. Theoretically speaking, it should be 2 inches straight across this whole thing. Exactly, if you put 2 inches worth of water in there.
Oh, that's right. I think I heard Citizen Z say something about this, and it sounded interesting. But with the aqueducts and rivers and stuff,
they don't
this
count.
same concept applies.
No, it doesn't actually. It doesn't.
It does.
No, it doesn't.
What do you mean?
Well, because the floor of these aqueducts aren't designed to make this kind of test. To me, this would be an actual scientific test.
Oh yeah, sure. Those weren't tests. Rivers are naturally made, and aqueducts made for the purpose. But I'm saying that it's the same concept of.
No, it doesn't. They don't prove what this experiment would prove.
No, I just said that they're not experiments. I'm just saying that these are concepts, but those aren't the tests. So yeah, you would have to make a test specifically for this. But rivers, that's how they run. They run because the elevation at that given point is higher comparatively than the one it's going to. So if you look at like the elevation of like the beginning of the Mississippi River, and you go to the elevation of what do you call that in Louisiana, you see that it's higher, even though there's supposed to be a huge curve. That curve's doesn't apply when they do the distance to sea level.
Yeah, well, my prediction is that the water is going to roll to each end until it overcomes the bend that's in the steel. Everything that I've experienced in life on a practical basis leads to that's what's going to happen.
Well, I like that. I like that. I just I haven't been thinking of. I heard him say it one time or say something about that. I wonder what it would take to make something like this. But and if I were doing it, I would do it smaller. But I don't know if that would make a bigger difference. But if you were doing like half a mile then you can imagine going down 2 inches on each side. I don't know if that would be enough, but
it might be. It's something I'd like to try, actually.
Oh yeah, I mean, it sounds, you know, it would definitely show something if it were done correctly, but that would be the hard part, is doing it correctly and making sure that this thing was actually curved or you know, as flat as you try to make it. So you'd have to have sensors kind of all over the bottom of it or something. I don't know.
Well, there's a salt flat that's 4 miles or 4 kilometers. I can't remember which it is. I think it's 4 miles squared, and they say that it's perfectly flat. Although I was talking to the boys over in Globe Earth Debate, and they're telling me that it's just smooth. It's not flat. It's not level.
Yeah. Yeah, so, I remember, I don't want to call somebody out who's not here, but he showed it to me. He's a real smart dude, though. But he showed it to me, showed me this huge paper that was written about it, or about some place that was really flat. Like the whole place is flat. It's a bit bigger than that. And at the very end of it, in the conclusion, they describe, as I said, first they turned it into the geocidal, and then the eclipsoidal. So basically, they had to match it. They had to match it to that model first, and then after they did that, they found it to be that level of flatness, which is still pretty. You know, it's still a cool flatness, but that's after they've matched it to the Earth, the supposed curvature of the Earth.
Yeah.
Can you tell me the Bunsen burner story again? Like what they figured?
Oh, geez. Oh my God.
What's the Bunsen burner story? This maybe I need to hear.
Well, they proved something about the stars with the Bunsen burner. I was hoping he would go over that again. They burned some stuff, and then they figured out what color it was, and then yeah, they said like the universe is expanding or something.
Oh, I don't know, it was a Bunsen burner. Oh, I think when you're talking about like when them were doing it like 300 years ago. I forget. So mad. I mean, I imagine a mad scientist doing this weird stuff, just burning stuff and checking it out. But the prisms that they use when they did this, and when Newton did it, and even the way they did it like 100 years ago on the not on the Hubble, but Hubble himself, when they did it on that, I forget what it's called.
So Newton was part of this burning stuff and using a prism?
Yeah, I forget exactly how they did that. I think they were looking at the fire and stuff, and like, you know, they don't have cameras or anything, so I don't know how they record it. But even guys like Newton, they would stay in their labs and in their you know, in their rooms or whatever for like hours on end and just like lock themselves in there. So I don't know what the hell they were doing, but the way they did it 100 years ago is they have like a whole bunch of prisms. It's like a matrix of prisms basically, and so they get the light really magnified basically, or what's the word when you split it up.
And how do they do it today?
They have machines. They have computers that can do even better than that.
So they like put metals and gases and just like everything they could find in there.
I don't know. Like I said, I really don't know what they do experimentally, but all I know is for stars, they don't need to know that many spectral lines. They just need to know like hydrogen, helium, carbon, oxygen, neon, and then you know, it gets rarer and rarer as you go, like oxygen, and then I think.
Well, wouldn't they have to do this with like the whole periodic table to some extent?
But these gases don't burn.
They do, but I'm saying when they're looking at stars, these are the only ones that they're really looking at because there's going to be nothing else in there.
What do you mean there's nothing else in there?
Well, stars can't possibly produce anything above iron, and iron's number 26, and even still, it doesn't produce everything. It
well,
has,
they
like,
knew this back then when they were trying to figure it out, though.
Yeah, I know, but I'm saying when they're looking at stars, though. Back then, yeah, they could have burnt everything. Like, I'm sure they have a spectral, like there's probably data online. We can look it up and see if they have everything. I'm pretty sure that I don't see why they wouldn't.
Like, who says they're even burning anything?
Well, I am. I'm saying that's how they first were doing it back then.
The stars.
Were you burning down blunts tonight?
Earlier when I was at my friend's.
What color does weed burn? I want to find that weed planet.
That's a good.
I want to blaze it down with Tosho someday.
Who says these stars are burning up anything?
I do.
Bunsen burner, bro.
Well, they're not. They're burning because of the heat, but that's not even how the lights.
What
created.
heat?
The lights created through the fusion. But the heat. You said what about the heat?
Like, what do you think these stars are made out of?
The hydrogen, mostly hydrogen and helium, and they're fusing them, fusing the hydrogen.
That's what he was telling us. He was telling us the story of how they figured that out.
And where's this energy coming from?
From that fusion, the equation E equals mc squared. It describes there's an amount of mass that's lost in the process, and that's transmitted into the exact amount of energy. But at the same time, the what do you call that? Because I forget. There's Feynman diagrams that show exactly what's happening for each one. But when you have a tritium, deuterium, these are hydrogen isotopes. When you fuse them together, like a neutron is lost, and I think a neutrino is lost, and then a bunch of energy is also is lost, and that energy is what we experience.
Wait, but flames have low radiant heat. Oh, it's not burning. That's what I'm saying.
It's not just burning. It's not burning the hydrogen.
Wait a minute. So you're saying it's a ball of gas that's burning in a vacuum?
Yeah, but it's not burning the way you think it's burning.
It's not actually
the energy
burning.
that's being created.
That's not my concern.
Nuclear fusion or
my concern is the ball of gas in a vacuum.
Mm-hmm.
Doesn't that go against the second law of thermodynamics?
No. I think people are confused.
Yeah, it does actually.
People are confused about that law. Because that law is true.
I'm confused about that law.
No, not you specifically. Even I was, and until you have to look into it. But that law describes the natural, the natural way that things are going to go. But that's naturally when there's influence work against this, and gravity can be an influence, and stronger the gravity.
So you're telling me that a ball of gas can create enough gravity to hold it together in what they call, for all intents purposes, a perfect vacuum?
Yeah, you have to remember that vacuum is extremely weak. It's not.
It's not extremely weak.
Yeah, it's the weakest thing that you can imagine. It's nothing. There's nothing there.
No, that's not true. Not when not beside a pressure system. What this gas, is it under pressure?
No, but the pressure system would be, and that pressure system would be the thing that has strength. And
so what's holding this gas together in space? Why doesn't it just dissipate like the law of entropy? So gas creates enough gravity to overcome entropy.
It all comes
when it's
down
as
to
big as the sun.
Kosha, on a scale of 0 to 10, how much do you love Flat Earth?
I love everything.
So how did this ball of gas get so big that it created gravity enough to overcome entropy?
Well, have you seen a nebula before, like through a telescope or on a picture?
How did this ball of gas become so big that it was able to overcome? Okay.
Yeah, so basically the gas by itself, it'll try and do its own thing. Usually they're going to move because something close to it is gravitationally attracting it. But when you have something like a nebula, when it's way bigger than the mass of the sun,
can you prove gravitational attraction of gas for me first?
I can't, but you don't have to really prove that gases can do it, just as long as you know that gases have mass, and then you can see. You have to test,
you've smelled the fart that just lingered and just stayed in the room and stayed together. It held its potency. You could have just used that example.
Yeah, there you go.
But the thing is, the entropy in that example would be stronger than the gravity. So when you have something small enough, entropy will win over the force of gravity. But when you have enough mass together, let's try to give a nebula as an example, because it's enough mass, but it's not close enough. It's much wider than our solar system. But over time, it may gather together, and once enough pressure is created through the gravity that it's forcing together, it might ignite a star, and then you have stars.
Coach, so serious question. Have you thought about going up for the Nobel Prize?
Well, you can't go up for the Nobel Prize. You just have to do something amazing.
Well, you're doing something amazing right now.
No, I'm not. I'm drinking in my car.
Drinking in your car.
Nice.
What are you drinking?
I think. Oh yeah, this is whiskey. Yeah.
Just straight whiskey or a little bit of water?
So you're driving around, drinking in your car, talking about flat Earth.
I'm not driving around.
Straight whiskey or a little bit of water? Clean or neat? What?
I usually have ice in it, but I don't think this one had any.
I don't think you don't even fucking know if there's ice in your drink. You're trying to tell us.
I picked this cup up.
I was just wondering what you were drinking, not like I was trying to determine anything. I was just.
Well, funnily enough, there's this whiskey called Rich and Rare. That's what it's called, and it's Canadian. And supposedly it's made by the brother of Crown Royal, right? So it tastes fine to me, but it's like $8 to $10 for a bottle of whiskey. So I don't know. I'm a Jew, so I always
you remind me of that guy in that movie, A League of Extraordinary Gentlemen, that if he looks at his portrait, he'll die. Like
Dorian Gray.
He just has to avoid looking at himself. Like,
well, no, that's not why. Basically his he stays young because his true age is like in that poster. I forget who wrote the actual book, but that movie was written, or the story was written by Alan Moore, who also wrote Watchmen and V for Vendetta. So actually, I like that movie.
You like that portrayal of you as that character, sort of the
Dorian Gray,
the mischievous one, the one that sort of creates all the
bad guy in that movie.
Sure, you got to admit that you're really, really into a topic that you don't even think is true.
No, it's
but was he really a bad guy?
Like you're super, super into flat Earth, but you don't think the Earth is flat, but you spend all your time. Isn't that kind of wild? Like,
it is wild. It's wild. It's definitely strange, but it's not the topic of flat Earth itself. It's sometimes the other scientific topics we talk about, and then also conspiracy theory topics, which so it's kind of a mesh of all that.
Okay, but like liquid.
Because there's other people that will go on your globe stuff with you. Sorry, Jax, go ahead.
It's all right. I was just making a small point is that liquid hydrogen is blue. So like, but the sun is like a yellow or.
Yeah. So like I said, I'll make a distinction. We don't have to get into it too much, but the distinction between
emission. It's supposed to be like redshifting at the same time.
Well, yeah, but don't forget there's emission, absorption, and then even reflection, and they're all three. They're going to be three different things. The emission and the absorption.
Determine all those by spectral analysis, right?
No, not the reflection. Reflection, you observe it just by looking at it.
Oh, you just observe like looking at it. Oh, that's
like whenever you look at something, like if you look at
the grass, that's a very interesting technique.
Yeah, everything that you're seeing is the reflection, and the colors you're not seeing is what it's absorbed. And so when you're doing the spectral, you really want to see what it's emitting, which is going to be more precise.
Do you think there was a deeper meaning in that movie, League of Extraordinary Gentlemen? A lot of different stories in there, that like stealing the weather and shit.
I'm gonna watch that again.
Alan Moore is really, if you notice, V for Vendetta and then Watchmen, and I didn't read that book, but I seen the movie for League of Extraordinary Gentlemen. It's very political, and even the end of Watchmen is exactly what I think a lot of people in here believe to be like a future, like the ultimate agenda, which it could be true. The government might be like faking an alien attack in order to bring the world together. That was exactly like what they did in Watchmen.
Well, they have to fake it because it's flat.
It will never work because all the Bible thumpers will be like, well, there's no such thing as aliens.
Yeah. What he said.
But if they were going to do that,
I'll show you the card that explains it.
So I'm going to stick with the man on the portrait, even though maybe you are more like Dr. Jekyll and Mr. Hyde.
I like to think of myself, I like Sean Connery because he's my favorite James Bond. But unfortunately, that was his last movie, too, was League of Extraordinary Gentlemen. But even just using that title and Alan Moore writing it, that was enough for me. Compare me to that, so I appreciate it. Compare me to anybody in that movie. I'll be the girl.
You're one of the calmest globe earthers out there. I mean, you and Rig, I think, are one of the two calmest globers to talk to that don't.
Riggs has me beat.
No, I don't know about that concept.
And me and Ratchet Man.
Yeah, Ratchet Man seems pretty calm too. And I don't know who me was. I missed who was talking.
He was talking with y'all all night. That was the dude who was talking.
Hey man, just write a book when you're done and share it with us, please.
I wrote a flat Earth book.
No, I want like a diary, bro.
You
wrote a flat Earth book?
Yeah. It's actually unbiased too, and it's not even what do you call it? It doesn't have like a result of like is it flat or is it a globe? It's basically it's actually kind of about it's basically it's almost a children's book, but for adults too. But
so
it's
you
just
are
like,
a flat earther then?
No.
Did you make money on that book? Are you rolling in on that book or?
No, I'm working on I'm working on having somebody make the illustrations.
Illustrations? What kind?
Well, it's supposed to be like a children's book, so it really just depends on the artist.
You can't draw?
I have different people, but they're not committed.
You can't draw?
No.
Do you want me to illustrate it for you?
Hey, if you're a good artist, dude, I'll get a percentage, I guess.
It'll be everything's flat in there, man.
Well, please make the pictures flat.
Hey, Jax, do you have a Kosho card in that deck?
Wait, hold on. I'm not biased.
Kosho card in that deck. I'm gonna make one.
Nice.
Dorian Gray picture. That might be me one day, because I don't think I'm gonna die until I'm at least 600, and I'll probably still look this young. So
wow,
I'll have a picture of the old man next to in my closet somewhere.
Awesome. Better hold on to that picture tight, man. Don't want to get into the wrong hands.
You know what affects gravity according, like, what kind of gravity do you believe in? Newtonian or Einsteinian or what?
Well, I was actually thinking about that tonight because, like I said, honest people will tell you that it's a belief. Obviously, it's not like I know what one way or the other to be a fact.
Mm-hmm.
But another thing is the Einstein space-time is not it's not necessarily it doesn't like debunk Newton. It's a adapted concept. It's not necessarily a replacement concept, because Newton assumed that it was the mass attracting the mass, like they had some sort of property to it that was attracting it to it. And then the way Einstein explains it is that there's space-time, and mass, like I said, warps the space-time, which will change the path of the other mass and then the light, even if it's big enough. And so this gives you the apparent. It makes it apparent that it's attracting it, but that's not exactly. It's not exactly that it's a property of the mass, like pulling it into itself. It's like the space-time that's being warped that makes the masses go towards each other. But that's the one that I abide to, but it doesn't mean it's the truth. I still firmly believe that someone's going to come along and they're going to like another genius type dude,
like Einstein, the flat earthers. Oh, I thought you were talking about the flat Earth people explaining that it's not there. Sorry, go on.
Yeah, it could be a flat earther, but I just don't think they're going to throw out Einstein's or Newton's. They're not going to throw out what we think of gravity, but they're going to change our understanding of it so that it can be included with what we understand about everything else. So that's the biggest problem, is that it doesn't fit with the other models.
So basically, mass has a factor to play in your gravity. Then
that is absolutely true. Like Newton's equation, I agree with, because it is true.
So I got another kind of mental experiment for you if you want to go through it, see what you think.
Go for it.
So just regular air has mass or weight to it, right? and helium has mass or weight to it, whatever you want to call it.
That's right.
So what do you think would happen if we took two balloons that had the same weight or mass? We can use the word mass if you prefer, had the same mass, and we measured how much air, just regular old air that we're breathing, we put into one balloon, and we measure how much helium we put into the other balloon, making them have the same mass, because helium does have mass and so does air. We know what it is. We can get those figures. So based on the volume that we put in these two balloons that have the same mass, we can make them have the same mass, one being with helium, the other being with air. Now, obviously, the one with helium is going to be blown up bigger than the one with air because it'll take more helium to get the balloon to have the same mass as the air one. And so now we have two objects that have the same mass. They will have the same gravitational pull from the Earth. So we hold them in our hands, we let them go. And one balloon, I reckon, is going to fall straight down to the Earth or the floor, the ground, whatever. And the other balloon is going to take off up into the atmosphere. But they're both the same mass. Gravitational attraction would be equal. Can you explain that?
Okay, so I'm sorry, I'm plugging in my phone. So in one case you have the helium and the whatever the other gas is, regular air.
Yeah.
Two things: if they're taking up the exact same volume, and
they're
have
not
the
taking up
mass,
the same volume. No, they're not. They can't take
okay.
up the same volume. The helium balloon will be bigger because it has to be, because it has helium. It has a less mass than air. So it'll take more helium to make the balloon have the same mass as the air balloon, right?
Yes, and is this in our
Okay.
atmosphere? Like you're talking about doing it on Earth?
Of course.
Okay.
That's
Well,
where we live.
Yeah, in that case, you would get the density of that balloon with helium in it, and because it was much bigger, had a huge volume, it would definitely not be able to.
Sorry.
Yes, sorry, my phone. Okay, yeah. So the helium would still rise up, and if the other one was the same air that you're breathing, and you put it in a balloon, it would just be the same density as the air. So it would have the weight of the balloon and the air, so it would fall. Yeah.
Right. So now we're talking buoyancy and density all of a sudden, right?
No.
Oh, we're
Basically,
not?
when people say,
Because
yeah,
sounds like what you just
density,
explained. You
yeah,
even used
density
the
has a
words
very
density.
small. Yeah, density has the smallest role ever to play in this, and that is it comes in when you're talking about a medium. So if you're in any medium, you first introduce the density of the medium and the density of the whatever you have. You
But
compare it
that's
real
where
quick.
we live, though, right?
Yeah, so that's why you have to do that
Okay.
here. And you compare them, and as long as it's more or less, then if it's more, then you can move forward with gravity. If it's less, then it's going to be buoyant compared to the atmosphere, and so it's going to rise.
So the helium balloon is anti-gravity, and the air balloon is gravity.
No, see,
Well,
buoyancy is like a derivative effect. It's not necessarily going up on its own force. It's actually being displaced by the weight of the atmosphere.
Coach, so if gravity was a woman, would you sleep with her?
You say sleep with who?
If gravity was a woman, would you sleep with her?
She
sounds like a heavy woman. Probably. Yeah, probably, I guess.
I was thinking like other.
Depends how much of that Canadian
ass.
whiskey's drinking.
I was thinking about Alice in Wonderland and wonder if you had seen the movies or explored the book and saw anything within that was interesting to you, so that you felt was.
I love that book.
Coach, so you're in world record time for how long you've been on the live stream today.
Yeah, I was talking the other day to somebody for some length of time. Depends on who's here, how tolerant they are.
Yeah. Are you listening like 24/7?
No, but sometimes I have it like when I'm working or something. It might be on. But I've been planning this measurement next week, and so I'm trying to find people to help with that. So I've been in here trying to see if people want to do that, but funnily enough, not a lot of flat earthers. But I'm trying to get a few flat earthers so that it makes it more sound.
To do what?
Like a debunking thing. Well, it's really for that Eric Dubay $10,000 thing to prove the spin and the curve.
Oh, you know he's not going to give you the money, dude.
Yeah, I know.
And you know you can't, by a scientific method, prove it. So
no, I can scientifically like the word proves not good for me.
But you can't use the scientific method, though.
Yeah.
You can?
Yeah.
What are you going to prove again?
Both the shape and the rotation.
Coach O's going to save the globe from all the flat earthers.
So
no, not necessarily.
What's this experiment?
Well, it's a measurement, and then the experiment's going to accompany it to show that the measurement is sound. But it's
so. What's your hypothesis?
Well, the hypothesis would be for the experiment, which is for the measurement. So you have to explain the whole thing. But the measurement is just going to show.
Oh, just say your hypothesis will work.
Say again, I'm sorry. Okay,
just the hypothesis for the scientific experiment.
The hypothesis to show that the measurement is sound is going to basically suggest that using the shadows of certain sticks and certain places at certain times can give you the shape of the Earth. Absolutely.
So we're going back to 400-year-old or 200-year-old or whatever it is.
2,400 years old.
There you go. 2,200 years old. There you go.
I was really hoping you were going to take a tape measure and measure that radius of the Earth.
I mean, that's really crazy that you're going to use a 2,200-year-old technique in today's day and age with all this technology.
I'm not using his technique, but I'm taking his idea and getting it precise. I'm gonna trust me. There's the way that I'm setting it up is going to eliminate any other possibility other than the shape I come up with.
Hey man, I'm rooting for you. Take Dubé's money. I want to see take Dubé's money.
How are you gonna set it up? How is this? How are you gonna set it up that's different?
Well,
Coach O's gonna use some dowsing rods. He gonna douse the curvature.
There's 3 dumbbells instead of 2.
No, yeah. No, if you wait for 8 days from now, actually a week from today, at 9 p.m., it'll be the equinox, precisely. And if you measure your personal solar noon at that time on that day, you should be able to get a pretty precise shadow. I can actually predict the shadows for any of you guys right now, and that's exactly how I'm going to set it up. I'm going to make the predictions the day before for everyone who's participating, and then we'll measure it. And the beautiful thing about that day is the number you'll get of the angle will be exactly your latitude. So your latitude is going to perfectly match your the angle of your shadow.
Could you not predict these same shadows on a flat Earth with a close sun? Smaller.
No.
Why?
You couldn't get these shadows because what you'll find is that there's equal distances between each degree of latitude. So 1 degree, 2 degree, 3 degree, they're all 69 miles apart. And you can't get that from angles that are coming from somewhere else. You could get that from a shape that we are that's angled, but you couldn't get that from, like, let's say if the angles were coming from the sun, 1 degree would be this distance, 2 degree would be that far. Okay, that could match. That's why 2 sticks could match. But the 3rd degree would be much farther than the 2nd one, and it would get wider.
Coach is doing a flat Earth experiment. He don't even know it, proving the sun is a physical object.
So you're gonna put the sticks You're gonna put the sticks 69 miles apart.
No, I'm not going to put them 69 miles apart, but I'm going to measure each latitude for every person that it is. And if you live at, say, 35 degrees north, you'll get 35 degrees north. And compare that to mine at 30, I'll get 30. And so, you know, the distances are already set. You know, they're on maps. So you don't need to measure the distance again. But, yeah.
Have you seen the post in chat?
Yeah, I've seen it. It's just wrong. It's a wrong meme. But yeah, that Dr. Zach guy
Can you
says so in
explain
his
why
video.
it's wrong?
Yeah, because those sticks on the flat map, the angle you wouldn't if those were the same angles, or if those were the same distance, they wouldn't be the same angles. If those were the same angles, those sticks would have to be much further on the flat one. And Dr. Zach, he puts that picture in his video and says this wouldn't happen in real life because it wouldn't. Just this picture is exactly why I'm.
So Dr. Zach's agreeing with you. 3 sticks will do it.
No, he's agreeing that this meme is no good.
Oh, I think you're 3 sticks to the win, to be honest.
Well, that's fine, but I'm doing more than 3 sticks. Yeah, and
you're 3 sticks to the curve, dude.
Yeah, you're 3 sticks to the curve, man.
Yeah.
How many sticks are you doing? How many? In all seriousness, how many sticks are you doing?
As many as possible, because the other parts of the proof video or the thing I'm doing involves other things, and so I have specific places where I need to do them. But you know, at least 20 or 30 more. Who knows?
Yeah, you'll be able to take down this image. It's a 2D representation, assuming the location of the sun, and when you start breaking that down over the ball, you'll be able to.
What about? So, are we going to take into consideration? What's the word I'm looking for? Elevation, temperature of the ground, temperature of the air, which way the wind's going, and all this other stuff. Oh, none of that stuff matters. That's interesting. Because it sure does matter whenever a flat earther tries to do an experiment.
About how far north or south.
Yeah, that does matter. The latitude does matter because that's what I'm saying. The latitude will give you the angle.
How far?
It depends. If you're 30 degrees north, you'll get 30 degrees. If you're or south.
Yeah, I'm just saying, like, what's far enough to say that, you know, this is enough.
Oh,
like,
I mean,
how far north and south would you have to have to prove the ball?
Arbitrarily, you could be on the equator. You could be at the you couldn't be at the North Pole actually, but you could be right south of the North Pole. You could be at 89 degrees north or 89 degrees south. The length of the shadow.
When's this gonna happen?
Next Saturday, 9 p.m. But you can do it at noon.
9 p.m.
9 p.m. is the precise moment of the equinox, but that's
the sun is out at 9 p.m. where you live.
I know. That's why I'm saying you can do it at noon because that 9 hours isn't going to make too much of a difference. You could do it. You know, I'm doing it today. I do it every day till then. It'll get more precise the closer it is to.
Wait a minute. So you need readings from a bunch of people across the world or something? Is that what you're saying?
Yeah.
Well, I'll help. I'll help. But here's the thing. I'm going to give you a fake one and a real one.
Yeah, I know. That's my plan. That's my plan.
Yeah, but I'm going to give you a real one.
Too much.
You should be able to determine which one is fake and which one is real.
Don't the lengths of the sticks matter too?
Yes. So I'm going to try to get people to use uniform sticks, but it doesn't matter if their stick isn't the same size as mine. It just looks better, but as long as I know the size of their stick and you know, so the size of the stick.
I'm not telling you the size of my stick or the length of my stick.
But the longer,
well, I'll do it. Hey, you could call me up. I'll do it.
Yeah, well, I appreciate it, man. I will. The more because the flat earthers, it'll make it'll just make it more sound. And
my stick's bigger than yours.
So tell me what a truth that you got out of Alice in Wonderland.
I can't think of. Oh well, she does say something. What'd she say? She says her dad said something about eight impossible things before breakfast or something. But I just like the guy who wrote it, Lewis Carroll. He was a crazy mathematician, like really crazy mathematician. But so I can't think of anything specifically about that book.
So you think there's a lot that's in there that has to do with math? like vortexes and shit like that.
Are you just gonna leave out the small detail that he was a fucking pedophile, or?
I didn't know.
Well, that escalated fast.
I didn't even know that.
So, has anybody ever tried to model your idea on a flat surface?
Yeah.
And they can't, and they can't get the same result.
I mean, it's mathematically, like, you can sit there and do it with whatever, but you can sit here. You can also draw it out. You can draw out these lines. I have a CAD where I've done that. I made a video of it too. But if you draw these straight lines and you assume the sun's close and has divergent rays, or assume that it's far away and has parallel rays and the Earth is curved, you can see what this will create. And like I said, when you have something that's far away or close up and it has divergent rays, those rays come in, the angles, they separate not equally. They get further apart as the angles get bigger and bigger.
So it's my question, though, you didn't kind of answer. So you cannot model same results.
I'll show you.
Do you say you can or you can't?
No, you absolutely can. You can draw.
No, I believe you when you say you can. So then, how does this prove anything? Then it can't prove either way. How am I mistaken on this? Someone help me.
Well, you're not mistaken, because it's not taking into account what we deal with in the atmosphere. So basically, you're saying that no observations need to be made at altitude in order to determine the effects that are being caused by the different layers of atmosphere. So you're discounting all the information as far as what the atmosphere is and any measurement regarding altitude and the effect on these shadows when you gain altitude.
No. That's the beautiful thing about noon is when you look at things like
noon at 9 p.m.
No, we're not doing it at 9 p.m. The exact moment of the equinox is 9 p.m.
Oh, I see.
But obviously we're gonna do it at noon. But still, the beautiful thing about noon is when things like refraction. If you look at how refraction works, it doesn't. It has a zero effect whenever it's perpendicular to the what do you call that? The split of whether the denser mediums or whatnot. And so at noon is really when you're going to have the least refraction, probably zero, but I can't say exactly zero. But yeah, it'll be the least refraction that you'll get, and that, and also the way that we're getting noon, we can look it up and it'll tell you your local noon. But we're also going to have I'm going to make sure that we're making the measurements with the shadows as well. So the shadow itself will tell you when it's noon.
Well, it's one of the greatest assumptions of all times. They've changed it many times. They went from 3 million miles away with the sun to 93 million miles away now. So the greatest thing in this experiment is assuming, the distance of the sun. It has nothing to do with the Earth itself. Shadows have to do with the light source. It has nothing to do with the shape of the Earth. Shadows always have to do with the light source.
Yeah.
You're right that it is involved, but very, very one small detail, like in the flat model, in order to get the
it's not one small detail though.
Let me tell you what the detail is.
Okay. I thought you were saying the light was.
In the flat model, the sun has to be at a precise range once you have these two sticks and the angles. The sun has to be at one fixed point.
That's the assumption.
Well, no, that's how angles work. But with the parallel lines, it just has to be further than a certain point. So as long as it's further than, I think, 500,000 miles. 500,000 miles. As long as it's further away than that, the rays will come in parallel. So
wouldn't you have to prove first that we're all looking at the same sun?
Yeah, but that's easy.
And prove that the size of the sun?
No, we don't have to prove the size of it. Just that the angles are coming in parallel. But you don't need either of those things to prove just that. You could prove that in your own city. You just measure the angles of the shadows in your city somewhere, and then somewhere else in that city, and see that they're the same, and then measure them in two different cities and see that they're different. And this will tell you that the rays are coming in parallel, or that they're coming in at precise angles. You know what I mean? So it's the same angle in the same city.
Yeah.
So basically, you're really not that concerned about peer review from the flat Earth side, because you're just going to dismiss everything that's said.
No, I'm not going to dismiss anything that. That's the beautiful thing. Also, is I know what kind of questions a lot of people ask, and that's why I'm doing it this way. I'm doing it in a way that once presented, there won't be any questions or concerns.
I gotta say, Kosho, you are dedicated, man. You're drinking in the car at 7 a.m. You've been up all night. You're dedicated to the server.
I'm back on that porch now because I gotta charge my phone.
I mean, I'm still here.
Talk to you.
It's 8:23 here, so I mean, I'm pretty dedicated to it.
Talk to you.
I just don't sound as sophisticated as Kosho, you know.
Yeah, he sounds like a smart guy. I didn't really get to talk to this kid, but he sounds like a smart dude.
Talk to you.
It's the whiskey talking.
I just started drinking too. I didn't even really get to drink tonight.
Well, I'm off tonight. Good night, guys.
Night.
Talk to you.
What's up, Scully? You're starting to weird me out.
Let me talk to you.
Yeah, I'm gonna go as well before this gets really creepy. All right, later.
Yeah, it's getting creepy already.
Let me talk to you. Let me talk to you. Let me talk.
What do you think about the movie The Matrix?
I love that movie. It's my favorite. I don't have favorites. Like I never pick favorites. I pick like top 5s, top 3s. But I could say Matrix is probably my favorite movie.
Tell me some truth you got out of that one.
I mean, it's not really like a true movie, but there's a lot of philosophical concepts in it.
You don't think they buried any truth in there, like with the powers that be or conspiracies or anything?
No, I think that those writers, I think the Wachowski brothers, Wachowski, whatever you say, I think, or whatever you want to call them now, the Wachowski siblings, sisters, I think they made it.
Talk to you.
But yeah, there's definitely, that's the other thing, is they're the concept of being, in the system and, being freed from the system and stuff like that. It is definitely, there's political, concepts with that. But also there's like, Christian concepts too, like with him being Neo, the one, he's like, he dies, comes back to life. He was like the chosen one.
The Oracle, the Architect, Morpheus, Nebuchadnezzar. I mean,
yeah,
Bong talks a lot about all these different names they use. I mean, yeah, Zion, Zionist. I mean, you're familiar with this term. I mean,
yeah, I've heard it. But yeah, the movie, yeah, it's because it does that. It wraps up the Christianity, like religion and philosophy, because there's a lot of philosophical concepts as well.
So you don't think there's like a machine world?
No, but it's very possible we could live in a simulation, like the same way that he was in, the real world, or he was in the Matrix, and he thought it was the real world. There's nothing that says that can't be our experience, because, you can't prove otherwise at this point.
If it was 100 years ago and you never knew what a computer was or any of that, would you ever have thought about the simulation theory? Would the simulation theory ever come to your mind as something? Because I'm pretty sure without computers, you wouldn't understand the concept of simulation.
Yeah, I think with I'm not that smart of a guy, but there was that dude who came up with the scientific method, the French guy, the Descartes, or Des, whatever you say, Descartes. His most famous quote is actually about that. Basically, I think, therefore I am. Like, that's the only thing that he can prove, is that he exists because he can think, but really his other senses are they can be fooled.
That's
Every
Shakespeare,
sense
man.
can be
What are you
fooled.
I think that's Shakespeare. I think therefore I am Hamlet.
No, it's not. It's Descartes.
Oh, is it? To be or not to be. Sorry, I missed it.
Yeah, I like Shakespeare too, though. He came up with the name. He invented a lot of words and names. He invented the name Jessica and some other ones too. You know, Dr. Seuss invented the word nerd.
All the world is a stage. And we are the actors.
That's
Do
true.
you think the machines could be like an analogy of the system like that exists today out to get us?
Yeah, yeah, kind
Using
of.
us?
A lot of people in here, they believe that the global thing is already complete, like they already are in tide. I think that that's their agenda, but they're not at the point where they've already completely have us. They have us close to it's like they're close to the end zone. They're like basically like high-fiving already because they're like already almost there, but they're still the final stage. And they haven't gotten. There's still a lot of stuff that can mess them up. So I'm hopeful about that.
There's a final stage.
Yeah. There's not a single government yet. There's not a single agenda yet. There's the United States since the 90s or since 1990, we had it. It's kind of like in a football game where it's like you got the ball back and you're already winning, and so it's like you're about to win the game, but it's just not over yet. Because there still is other enemies. It's just not like there's not like two top dogs going against each other. But I think it might go that way
What if you're like 2 touchdowns ahead?
Is there a moderator on this chat right now?
Yeah, I'm here. What's up?
I was just wondering if Manar, if he could get a flat earther one, whatever they call it.
Sorry?
Roll. If he can get a flat earther roll, as he believes the earth is flat. Unless you want to have a talk to him in the interview chat.
Sure. Tell him to join interview.
Join interview. Manar.
I just want to give you guys a quick advice or something, suggestion. I don't know. But I'm sure you're aware of this, but their trolls have actually gotten a little bit more sophisticated in the sense that there's a lot of people convincingly pretending to be flat Earth and coming in here and getting flat Earth rolls.
Yeah, they've infiltrated. We know.
I see it quite clearly. And then some of the people like they'll do something fucked up. Like I think there was a kid in here like talking about his age or something. And so I'll be like, hey man, don't do that or this or something like that. And then like, hey man, don't worry, I'm just fucking with these people. I was like, okay, dude, well, they're gonna catch you. Well, there was a dude who was in here for a while. He ended up getting like
all
silver.
will be assimilated. The resistance is futile.
Well, I think once they have full control, it really will be. That's the danger. That's the thing that people forget about is that like right now there is nothing, especially in our country.
I was talking about the trolls, Coach.
Yeah, I know you were. But I'm just going back to
if they slip in, well, you're not gonna see them again. Say bye-bye, Globe. Bye-bye,
there was a dude. They get off to making fun of globe earthers. Like they'll sit in there and they'll just bash globe earthers, and some of you guys are like high-fiving them basically.
Like so you might have an interesting perspective on this. Do you think Agent Smith was a good guy or the bad guy?
He was a bad guy. I mean, he was
sure?
Yeah. I mean, he wasn't even. He's such a weird concept, like in the later movies, but in the
like Gravity,
I guess, because he was like trying to be freedom, but he was like a selfish freedom. You know what I mean? Like he even at the last movie, he's like making everyone clones of himself, and he wants to be like the only program. He's pretty selfish, dude.
Is that what you got from it?
Well, from the last ones, but the last couple ones they make less sense than the first one. So I think they tried too much to make it like really philosophical, and it kind of was like less philosophical. But I don't know. Maybe you got something different from it. I don't know.
Well, was Agent Smith and Neo one and the same?
I think they were trying to say something like that towards the end, but I honestly don't. It's even just a weird concept, like the one and stuff like that. If like the way I think about it is, like once you become aware of that, that you were in the Matrix now, and you can do these hacks, basically, like you can hack the system. It would seem that almost anyone could. Like it wouldn't be like there would be one special person who can do it better than everybody. But that's why it's a movie, it's telling a story, and so that's just my interpretation. That's the way.
Wasn't Agent Smith trying to destroy the most evil thing, the Matrix itself, the machines turning humans to batteries, and
which is also robots would have just killed us.
The machines that were trying to kill everyone. And I mean, if there was no Agent Smith trying to destroy that system that kept them supplied with the energy they needed, there would be no more machine world, right?
He had an objective.
So I don't know. Lots of twists and turns in the plot of that one. Kosho, we can't hear you, man. I don't know what happened. Someone mute you or something. Did you finally someone get enough? I think you might have pushed the button yourself, though. And you can't hear me.
I think he's not in the room anymore. Somebody might have kicked him from somewhere else. I was gonna ask him.
Well, I just server deafened him. I don't know who did that.
Oh no, okay. No, sometimes people do it to just like messing around, not messing around, but they'll do it without saying anything or something. So, okay. What were you saying? Oh yeah, about Agent Smith. Like programs have objectives. That's because I'm a programmer myself. So, computers may eventually find their own will and like do things. Do things like, but there's always a purpose. There's not like no purpose. And so, him in the movie, if you really think of it as a real thing, like he had an objective, and he was working with the machines. The machines programmed him to find these anomalies and take care of them. And so it would seem if he was really just that agent, like he wasn't like having his own agenda, like his reason for finding those dudes and stopping them was the objective he was programmed to do. So that's why it's also weird in the later movies why he even cares about those dudes anymore.
Well, and the fact that he can exist outside the Matrix, right?
Which is also weird. I actually didn't get that. Like how Neo has powers outside the Matrix.
Well, it tells you that he's, of a different nature. Like him and Neo can be one because he's like a spirit, right?
Yeah, I guess so. Honestly, I never got it. I never really took time to think about that. But yeah, because it's weird that Neo, like again, he has powers outside the Matrix, and yeah, you're right. He can come out of the Matrix and go in other people's bodies, like real bodies. I didn't know if that meant like they were in another Matrix, like they were in a Matrix also. I don't know.
I can hear that. I see it. It's a possibility.
Actually, I really only like 20 minutes of that movie.
Do you know who the one? Do you know who the one is, though, Kosho? Do you know who the one is in the movie?
In the movie, yeah.
Mm-hmm. Who is it?
It's Mouse.
Who?
That one's Neo, man.
Mouse?
No, it's not. It's not Neo. That's what I mean. Like, how can you be this initiated and not know who the one is in the Matrix?
When I said initiated before, that doesn't mean like I'm initiating you into a cult. It just means someone who's they're not aware of it yet or something. But no, who do you know
who the one is? Take a guess. I don't think I know who the one is. I mean, you should know.
Don't think you are.
Right? If you're no, seriously, take another guess, man. If it's not Neo, who else could it be?
That little girl at the end, the little Indian girl?
No, man. We just talked about Neo and his polar opposite, dude.
Oh, you're talking about the
who else can do what Neo does? Who can do what Neo does?
Yeah, I know you're talking about the Agent Smith, but he can't really do what Neo does. But
Agent Smith is the one, not Neo. Dude, you gotta go like watch that part again with the where Neo's talking to the architect. You gotta watch the part where Neo's talking to the Oracle. Neo isn't the one; it's Agent Smith. I mean, seriously. Like,
where do you see that? I remember he talks
the Oracle tells him. The Oracle tells him he's not the one. The architect tells him that he's not the one.
The Oracle tells him that in the first one, but the architect never tells him that.
See,
he tells him that there were other ones in other matrices.
First of all, you have to understand what the Matrix teaches. The Matrix teaches this determinism philosophy. Fate, causality, everything. If there's a cause and effect. So it's starting from there. Then you look at these programs. Okay, so this whole the one thing in itself, this waking up, these people waking up in the Matrix, is in itself another control within the Matrix. Are you getting it? Like Neo waking up and these people unplugging from the Matrix. Okay, that's not. This has happened 6 times over, over and over and over. You got to remember that too. So over and over, this keeps repeating and repeating. So now we know. But Neo is one of those people. Every now and then, somebody would be born into this Matrix that can do these things. So dealing with that anomaly is something called Agent Smith, the one. So the job is to return Agent Smith to the source. That is the whole point here, is to return the one to the source, to the architect, so that they can start over again. And Neo was the instrument to do that.
Oh yeah, I guess you're right. Because he does.
It gets deeper though, but so with that new perspective, right? Or if you didn't know that before, you got to look at it again at the Matrix. I didn't know what this thing was. I thought Neo was the one, but no, it's just, and you have to also look at what it's implying. Like, what does it mean? What is this new age? What are these ideas that this is trying to teach you? Like that they're trying to. How do you put it? Initiate you.
It's not trying to teach you something, but but I see. But if that's true though, then wouldn't they both be two sides of the same coin that is the one? Like both of them together, because they're both being brought to the source. Yeah, something like that. Possibly, I don't know. Like he exists as he's the anomaly. By the way, it wouldn't be Agent Smith. Agent Smith would be the thing that the part of the system that's trying to correct the anomaly, and so he kind of
it's sort of like when the Merovingi says, "I survived your predecessors, and I'll survive you." The architect, echoes it as if Neo and all his reactions and actions are already understood. The anomaly is Agent Smith.
Well, no, but I think Agent Smith would be they would both be part of the same anomaly, because Agent Smith exists because now the anomaly exists basically, and so it's like they kind of feed off of each other.
Well, there's also another thing that's been added to it. See, the choice that Neo had to make. Okay, we know, the architect knows what's going on, so he tweaked it a bit. What if this Neo guy, right? What if he were more loving, right? So he tweaked Neo to make the decision to choose love, to see what would happen then. He already knew he was going to choose to go save Trinity. So it's a change that the architect made to see how it would play out, after everything, and it caused a change in the Matrix. So it's all predetermined anyways in the end. No? What do you guys think?
I don't think the architect, he didn't create Neo though.
Well, it's debatable.
It's math. So he knew that these guys. So as these guys came in, the 6 times they came in, he did this. He is simulating what would happen If I tweak Neo to be a bit more caring about Zion, what would happen? Well, he would say Zion and we'd repeat all over again. Nothing changes. But what if I tweak Neo to choose love? And what did they say about that choice? That love is a human weakness. So, these are the messages.
Yeah, that's what a
there's
robot
so
would
many
say.
other messages, but that's one of the many themes of these shows. That you being human is not enough. Yeah, that you're just a mistake that God made. Like God could not create a perfect world, therefore He had to create this world with sin. I mean, with Agent Smith representing the devil slash Jesus representing Neo, and this dealing with this anomaly called sin. God is incompetent. He couldn't create a perfect matrix for everybody to enjoy and love. I mean, amongst other themes that this movie is pushing. You guys think about that? Crazy?
Well, I
No,
think
man.
if the
I think you're on it.
architect. I'm sorry. Go ahead, Tim.
No, go ahead. You have a clear thought through this.
No, I was just saying. I think if the architect was like if they knew about if it happened 6 times before and it was gonna happen again, I think or what Neo is or whatever, or whatever the anomaly is, it's more of a probability type of thing. It's like because the system has so many different people that they're like the anomaly is the one like it's eventually gonna happen, maybe not precisely when, but it's gonna pop up, but kind of what. So I don't think I'm not sure if exactly, and this is just me fucking making it. I didn't write the movie or even talk to him about it, so just making up whatever I think of it. But I just don't think that if it were based in reality, like the architect would have known when this was going to happen or even controlled his emotions. I think he probably could have planned it once he sees it, like plans the things around it. But even still, he can't like make Morpheus and Trinity and everybody else do or think and do whatever they think and do. Like, even though Neo he was able to see it beforehand, though. So that's weird. I don't know, man. I think that's why people don't like it that much. Is because it seems so like this. The second and third one, it gets more profound, but then it's like
right. The Merovingian said. The Merovingian said, "Choice is an illusion." So that's out the window. We know that their choices were influenced because because of that and the conversation Neo and the architect had. I mean, probability and statistics is just math. Thing is chance in a computer.
Well, I think there's no such thing as chance when it comes to this movie. You just look at the characters, the key maker, interesting concept, just the whole idea of what the key maker symbolizes, and the train man, very interesting character. The little girl, super interesting. The Oracle, all different ideas that sort of bring this thing to a whole different level.
Yeah. No, I definitely. That's why it's my favorite movie. The second one and the third one don't count. Like the trilogy is not my favorite, but the first movie is my favorite movie for sure.
Yeah, the depth in the first one is for sure. The second and third, I know what you're saying, and the more cinematic, less to chew on for sure. But as a whole.